Hello, good evening. Hi, Sintong, there's only you today. Where's the rest of everyone? Okay, luckily we are not doing something heavy today lah. We are only doing chapter 8, just the beginning part here. Okay, not gonna do something heavy. Okay, so are you ready? Are you ready? There's not even what's happening right now. Okay, so guys, should I say just you alone here? Okay. Hello, Sintong. Shall we go to 8.1? Do you have your chapter 8 notes? This is together with your chapter 7, which was the last chapter, the hormone chapter. Okay. Should be your July notes. It's both together. It's both attached together. Okay. Do you have it? Do you have it? If you don't have it, then you have to use the paper and write it down. Oh yes, okay, then good. Okay, so let's begin with 8.1. This is matter. This chapter, starting from this chapter, it's gonna be biology. Sorry, it's gonna be chemistry already. There will be no more physics. Sorry, there will be no more biology because biology we have officially done. Okay, no, the hormone chapter, the joints one. Okay, and the genetic one. All right. So, Sino, when's your exam, by the way? When's your exam? And I believe your exam should cover until chapter 6. Okay, I'm guessing should cover until chapter 6. So if it's like that, then yeah, chapter 6 lah. Make sure you get, if you need, get your video from me. Okay, if you want to. Okay, so shall we look at 8.1 matter? Okay, this is not coming up for your next exam lah, your coming exam lah, because this is quite new. Okay, so let's talk about particles today, shall we? Particles. Okay, when we take things into the smallest, it's called particle, 分子. Okay, 分子. This is called a particle. And we have 3 types of particles. Okay, we have 3 types of particles. I am sure you have at least heard of atom. Have you? Have you heard of atom? Atom is the smallest particle of an element, right? If you take things apart to the smallest point, that is your atom. Okay, that is your atom. So it is the most basic unit in an element. Just think of Lego. Okay, just think of Lego. If this world is made of Lego, if you take the Lego to the smallest piece until you cannot take it apart anymore, that is your atom. Okay, that is your atom. So atom is the smallest thing in the world. All right. So what about atomic substance? Okay, what about atomic substance? What is only made from atom? Example of atom. Example of things made from atom. Okay, listen here. If something is only made from atom, if something is only made from atom, it is a metal. It is a metal. Okay, for example, if I have a piece of iron, here, if I have a piece of iron, that iron inside, pure iron, inside there's only iron atom. Okay, there's nothing else, no other atom. On another example, if I have a piece of gold, if I have a gold bar, inside the gold bar, if it's 99%, 99.9%, then this is only gold atom inside. There's only gold atom inside. Okay, you get what I mean? You get what I mean? So if I tell you something is only made from atom, if it is an atomic substance, it is fully metal. It is all metal. Okay, 99% will be metal. Okay, then what about the other 1%? What about the other 1%? The other 1%, we call it inert gases. Okay, these are very special gases. You know, helium. You know, it's helium, the thing they used to fill balloon. You know, your birthday balloon, the one that floats. That is your helium. Okay, helium. And these guys, we call it inert gas. What does it mean by inert? Inert means no reaction. Okay, inert means no reaction. If I talk to a crowd that is very inert, that means they don't laugh, they don't reply, they don't do anything. So that's your inert, right? So if I tell you again, if I tell you something is made from only atom, mostly you can assume it is a metal, or in a rare case that they are inert gases. Okay, only very rare case there will be inert gases. Okay, like you see, zinc and iron, these two, they are metals. All right, zinc is only made from zinc atom. Iron is only made from iron atom. Okay, gold is made from gold atom. Copper is made from copper atom. Silver is made from silver atom. If you get what I mean, right? And then you have helium and argon. These are inert gases. Okay, these are inert gases, and we have inert gases at the last row of this thing. Do you remember what is this? Do you remember what is this? This is what we call our periodic table. We see this thing in Form 1, I guess, if I remember clearly. Okay, this was in the Form 1. Okay, anyhow, so let's look at the next one. Next, we have molecule. Okay, next we have molecule. So we have atom being the simplest, but when you add atom and atom, when you have atoms, it's called molecule, right? It's called molecule. Okay, I'll give you an example here. Can you see this is this one? Ilia, one red ball is your oxygen atom. And then you have another oxygen atom here. And when you stick both together, these two, we call it oxygen molecule. Is it okay? Is it okay? So we have oxygen atom, oxygen molecule. Atom, atom, molecule. So same goes to water. You see, water is H2O. So you have two hydrogen atom, you have one oxygen atom. So this is your water molecule. Water molecule, because this is 2 and above. So very simple here. As long as you have 2 or more atoms, then it's a molecule, right? Atom, molecule, 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 molecule. So you have many, then it's a molecule. All right. So what about molecular substance? Okay, just now I say, right? Just now I say, if something is made from atom, it is mostly metal, or in rare cases, it's inert gas. Okay, so you see, atom is metal. What about molecule? Molecule is non-metal. So you see, atom, metal. Molecule, non-metal. Again, atom, metal. Molecule, non-metal. Right? Because just now you see, oxygen gas. This is the oxygen you breathe in. It's an oxygen molecule. Is this metal? No. Water. Is this metal? No. It's molecule. Both are molecules. Both are non-metals. Right? So whenever you see molecule, you will think of non-metal. When you see of atom, you think of metal. Okay, can understand? Can understand? So you see, you have examples here: naphthalene, water, and oxygen. What is naphthalene? What is naphthalene? Naphthalene is what we call mothball. I'm not sure whether you heard of this. Mothball. The thing you put in your cupboard to chase away moths and to make your cupboard smells bad. This thing. So this is your mothball. All right. So it is a molecule. It is a non-metal. Okay. So far so good. So far so good. Are you okay? Are you okay? I mean, your exam doesn't cover this, right? Okay, so you just learn this for fun This is gonna be in your next exam. Oh, the good thing about this, right? The good thing about this, in your final exam, this is for sure coming out, and this is like a must score. It's like a free mark for you. Objective is coming out, subjective is coming out, so it's free marks for you. So my students usually will get most of the marks here because it's very easy. Okay, nothing much to memorize here. No biology stuff. No. Yeah, it's boring, but it's easy. Okay, so atom, metal, molecule, non-metal. And then let's look at the last one. Okay, this is ion. I'm not sure whether you heard of this. In Mandarin, it's called 离子. Okay, 离子. You know, 正离子, 负离子, positive ion and negative ion. So that's your ion. So ion is anything that has charge. What is charge? Just like you charging your battery, Charge means anything. Okay, I'll write it clearer here. Na+. This is called sodium ion. Cl minus, this is called chloride ion. Okay, anything with charge means they have positive, negative. Okay, so when you're charging your phone, you're putting negative into your phone because your phone has charge. So charge means positive, negative. Okay, positive, negative. So whenever something has positive or negative charge, that is an ion. Okay, so that's your ion. Right, so what is ionic substance then? You see, just now, atom is metal. Okay, we ignore the inner gases. Atom is metal. Molecule is non-metal. Then what about ion? Ion is metal plus non-metal. Metal plus non-metal. For example, sodium chloride. Sodium is a metal. Chloride is a non-metal. So what is sodium chloride? What is sodium chloride? Sodium chloride is your salt. Salt is an ion because it has metal inside and it has non-metal inside. So when the metal and the non-metal, they react, you get salt. Right? And then ionic substance, they all look like salt. They all look like salt. They are like grainy, 一粒粒的. Okay, like what else is like this? What else is like this? Iron oxide. You see, iron is the metal. I'm just gonna write positive here. Oxide is the non-metal. So what is iron oxide? Iron oxide is actually your rust. Your rust. Okay, that's when your iron gets oxidized. When your iron marries oxygen from the air, you get an ion. Okay, which brings me to this. You see, things will change. You see, things will change. Like you see, iron atom, atom means metal, right? Atom means metal, right? So when you buy a new hammer, that is iron metal, iron atom, right? But if you don't take care of it, you put it out in the sun, you put it out in the rain, sooner or later, it will form rust. So rust is iron oxide, and this is our ion. You're changing atom to ion, that's why they corrode. That's why they become rust. Okay, make sense, Make sense, So things will change. Sometimes they will go from atom to ion, they will go from molecule to ion. Depends. Okay, so three things to remember here. Atom, molecule, and ion. Hello, Sinton, are you okay? Are you okay? Did you get disconnected? Okay, or you change device, is it? You change device, is it? Okay, so atom, molecule, and ion, atom, molecule, and ion, so just remember this, so atom, metal, molecule, non-metal, ion, metal plus non-metal. Okay, this one easy. Do you need me to repeat this? You actually learned this in Form 1, if you remember. Okay, what is inside an atom? Your atom inside has proton, which is the positive. You have neutron, which is the no charge one. And you have electron, which is the negative one. Do you remember this? You learned this in Form 1. Okay, as you can see, proton, positive, neutron, neutral, electron, negative. This one I think you should know lah. You should know lah, which was in Form 1. Okay, I don't blame you if you forget, because most of my students also forgot already. It's okay, right? But now you remember. So atom, molecule, and ion, atom, molecule, and ion. Okay, I'm not gonna do too much today. Maybe we'll end our class early, who knows, right? Because you are having your exam soon. I don't want to go too far because there's no point. Okay, so let's look at our periodic table, shall we? Okay, if you remember, we kind of touched this in Form 1. Okay, do you need to remember this? Do you need to memorize this? Do you think you need to memorize this? Yes or no? No, yes, you're correct. We are not memorizing this. Okay, so what is this for actually? What is this for actually? You just know how to read them. You just need to know how to read them. You just need to know generally their trend. Okay, what do I mean? First of all, let me introduce this. Okay, your periodic table is where all the elements are. These are all the Legos available. These are all the atoms available. Okay, we have 118 types of Lego in the world. Okay, so I just want you to know this. The yellow side The yellow side, they are your metals. Just think of them as guys, as in 男子 males okay? And then the girls are always on the right. The blue ones, the girls. Okay, in Mandarin we say 男左女右, guys left, girls right. Okay, or you can just remember as boyfriend, girlfriend, girlfriend is always right. Okay, girls are always right. Okay, this is how I remember. So guys are on the left, girls on the right. And what is this red color one? Okay, these red color ones, we call them semi-metal. 半金属, semi-metal. Why do we call it semi-metal? Because they're like halfway. They're like halfway. You see, semi-metals, they're very weird. You see, okay, you see, your metals, they are very good conductor. They can carry electricity very well. Okay, they can carry electric very well. Non-metal cannot carry electric, 不导电, cannot carry electric. But semi-metal, right? Semi-metal, they carry half. They are half good, half not good. You see, they're like halfway. They are something like a guy, but not like a guy. So we just call them semi-metal. They are just weird. The red ones, they're just weird. And just remember them as 1, 2, 2, 2. Can you see? 1, 2, 2, 2. And it looks like a step. It looks like a ladder. So it's 1, 2, 2, 2. So after you get that 1, 2, 2, 2, starting from this corner here, 1, 2, 2, 2, all the left side is guys, all the right side is girls. Really, really easy. Okay, that's what you need to know now. That's what you need to know now. All right. Do let me know if you want to slow down, because I have quite a lot of things to say here. Okay, we are not going to memorize these things, but we are going to know why are they arranged this way. Can you see a hole here? Can you see a hole here? You're like, why they cannot just arrange everything nicely like that? Why must leave a gap here? There's a reason for that. Okay, before I move on, let's look at, for example, aluminium. Okay, let's look at, for example, aluminium. You see, aluminium, right? How do you describe where is it at? If I were to ask you, where is aluminium? How do you describe it for me? You see, if where is technetium, how do you describe? Sorry, TC is here. Where is iridium? Where is it? You see, it's very hard for us to tell. We can't imagine you're on a phone with me. I ask you, okay, where's aluminium? You're like, how do you count? That's why we have a coordinate system. Do you remember what is coordinate? You learn this in maths. Cartesian plan, coordinate. When you draw a graph, you talk about the coordinate, correct? You have your x-axis and your y-axis. Correct, so if you have a dot here and it's 3, 5, then people will know. That means this is 3 boxes to the left, 3 boxes to the right, and 5 boxes to the top. So 3, 5. Okay, so this works the same way. We have x-axis, we have y-axis. But instead of call it x-axis, we have a special name for it. X-axis is called groups. Okay, x-axis is called groups, and y-axis is called period. Okay, x-axis group, y-axis period. This one you need to know. This one you need to remember. Okay, again, x-axis group, y-axis period. Okay, so now to describe aluminium, it's going to be really easy because see, where is aluminium? Where is aluminium? Aluminium is in group 13. We always say X first, just like coordinate. We always say X first. So aluminium is in group 13 and it's in period 3. Understand? Understand? So group 13, period 3. So by saying this, group 13, period 3, I will know, okay, group 13 means I go 13 boxes to the left, to the right. Okay, and period 3 means I go 3 rows down. Just this is how the coordinate system works for your periodic table. Okay, are you okay with this? Are you okay with this? Okay, so far, you see, guys, girls, half guy, half girl, group, period. Okay, so far this is what we know. All right, so let's explain. Why is there a gap here, sir? Why is there a gap here, sir? How is the periodic table arranged, by the way? Okay, by the way, how do we read the periodic table? Okay, please highlight this. Please highlight this. We arrange the elements by increasing proton number. By increasing proton number. So what is proton number? You remember what is proton? Proton is a positive, right? Proton is positive. So we arrange it by increasing proton number from proton number 1 to proton number 2, proton number 3, 4, 5, 6, 7. We increase the proton number. Not electron, not neutron. We don't follow these. We just follow the proton. Why? Because proton is the ID number. Proton number is the ID number. Okay, what do I mean by ID number? You have your IC, right? You have your IC, right? You know the last 4 digit of your IC? You know the last 4 digit of your IC? The last 4 digit is always the same, right? It will stay with you to the day you die. Your IC number will stay with you until you are gone, right? So same goes to them. Same goes to them. You see, okay, so who is number 1? How do we read the periodic table? Just like how you read your book. So how do you read a book? You read it from the top left, correct? You read it from the top left, all the way to the right, all the way to the bottom. You understand? You understand? We just read it like how we read our book. So this is proton number 1. Can you see the number 1? Okay, proton number 1. And then we fly all the way here because we read the first row first. Proton number 2. Then we go down. Proton number 3. Proton number 4. Fly there again. Proton number 5. Proton number 6. Proton number 7. 8, 9, 10. So can you see that's the ID number? So for example, 7 is nitrogen, right? 7 is nitrogen. Nitrogen will forever be 7 unless the thing is gone. It hasn't been gone for a few billions years. Okay, for a few billions of years, nitrogen has been here. So it's like a class that has never dismissed. If you are number 7, you will forever be number 7, right? So number 7 is always nitrogen. It has been, okay, it is now, it will be in the future. So it is always 7. So we just go all the way lah. So you just go all the way, you see, proton number 1, proton number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 all the way. So this guy should be the heaviest. Okay, so the more right and bottom you go, the heavier they become. Okay, the more right and bottom, the heavier they become. Do you understand? Do you understand? Okay, you're not memorizing anything. You don't need to know anything here. You just need to know the more right you go, the more down you go, the heavier they become. So this guy is the heaviest. This guy is the lightest. Hydrogen is the lightest element in the world because there's only one. There's only one ball here. Okay, helium is the second because helium has 2 balls. Lithium is the third because lithium has 3 balls. And it goes on, right? And it goes on. All right, so increasing proton number, increasing proton number. So 1 and 2 and 3 and so on. Right. Still, it doesn't answer our question. It still doesn't answer our question. Why is number 2 here, sir? Why can't we draw 2 here? The make sense thing to do is to draw 2 here, right? Because 1, 2, 3, 4, 5. It should arrange like this. Who the hell make it this way? Why is there a gap here? Why is there a gap here? Okay, this one, very easy. You see, it is purposefully done this way. Yes, this looks ugly because it has a gap there, but hang on a second. This will make a lot of sense. You know why? You know why? Because I arrange my elements in such a way that everything in the same group. Okay, let's say this is group 1. Group 1 is the first row, isn't it? Group 1 is the first row. You see, everything in the same group, okay, everything in the same group, they have the same chemical property. Again, same group, same chemical property. That means they behave the same way. If you are in the same group, you will all behave the same way. Okay, what do I mean? What do I mean? Okay, let's look at group one. Let's look at group one. Okay, group one, we have hydrogen, lithium, sodium, Na is sodium, K is potassium, rubidium, cesium, francium. Okay, which one have you seen before? Which one have you seen before? Which one have you seen before? Have you seen hydrogen before? Okay, hydrogen only. Okay, what will hydrogen do when you burn it? What will hydrogen do when you burn it? Can you guess? Is hydrogen very reactive or is hydrogen not reactive? Is it very reactive? Is hydrogen crazy or is it very chill? Take a guess. Take a guess. Is it crazy, 神经病, or is it like chill? Chill lah. Chill lah. Okay. If I use hydrogen to fill your balloon, is it okay? Then why use helium? You know helium? You know helium? Your birthday balloon is made from helium. The floating balloon is by using helium. You see, helium is the second lightest in the world. Why not we use hydrogen? Right? Right? Because, you see, because this guy is very chill. Helium is very chill. You burn helium, nothing's going to happen. But hydrogen, when you burn it, you will hear a loud pop sound. Correct? You hear a loud pop sound. You remember this in Form 2? So you hear gila pop sound. That's why this guy is not chill at all. Hydrogen is very explosive. They are very crazy. So you say, sir, I know hydrogen, but I don't know lithium, I don't know sodium, I don't know potassium, I don't know rubidium, I don't know cesium, I don't know francium. I don't know anything. But you see, as long as they are in the same group, they should behave the same way. You get what I mean? If hydrogen is freaking crazy, what says them? How do you think sodium will react? How do you think potassium will react? How do you think lithium will react? They are also freaking crazy, right? Just to tell you something, all these elements, everyone in group one, when they touch water, they will explode. Just by touching water, you don't need to put fire. No, water means explode. Okay, I'll show you this. Okay, let me show you this. Okay, what happens when you throw potassium into water? What happens when you throw potassium into water? Hang on, I'll let this thing load a bit. Oh my god, why is it so slow? Okay, you know what? I'll go Google for you faster. Okay, so you see sodium with water. You see they will freaking explode. The moment they touch water, they will explode. Right? Potassium, same thing. Okay, potassium, same thing. You touch water, they will explode. Different fire lah, you see? They will crackle and explode. See? All crazy. Everyone in group one, we don't mess with them because they're freaking crazy. But okay, you know what is lithium? Have you heard of lithium before? Have you heard of lithium before? Lithium is the thing we use in our rechargeable battery. Your phone battery is made from lithium. Okay, this is why you have always heard of cases that phone battery explode, right? Power bank explode, electric car explode, vape explode. Whenever you are playing with lithium, you are playing with fire. Then, sir, why use lithium as battery leh? They are so dangerous, they will explode. Why use lithium? Because until now, lithium is the cheapest and the best. Right? Sure, yes, lithium is freaking crazy, but we have no choice because there's nothing else. Lithium is the best to use. Lithium is the cheapest to use. Right? Because to make battery, we need something cheap and we need something good. If it's expensive, no one will buy it. If it's not good, then no one will buy it. We want something good and cheap. So the best and the cheapest is going to be lithium. That's why lithium is very dangerous. That's why when you play with rechargeable battery, Okay, let's say phone battery. Let's say phone battery. Okay, if you change your phone battery nowadays, you cannot just change it like that. They are sealed inside. Okay, they're sealed inside like this. Okay, and usually you will see them saying that do not puncture, something like that. Okay, so these battery there will be a warning that says do not puncture. Means you don't use something that and poke on it because this thing will just catch fire. They are freaking crazy, right? Phone batteries, they are freaking crazy. So yeah, that's why you don't mess with them. So you see, everyone in group one, even though you just know hydrogen, you don't know all these, you can just kind of guess it. They are all freaking crazy, right? That's why there's a gap here. You see, there's a gap here. Why is helium all the way back? Why is helium all the way back? Because like I said, you remember what is inert gas? You know, atom, inert gas. Inert means no reaction. These people, they are the chillers in the world. You see, all elements will react, will create reaction. Everyone in inert gas, they are chill. Helium, neon, argon, krypton, xenon, radon, they are all chill AF. You put acid, you put alkaline, you burn, you do this, you do that. Everyone is going to chill and say, not interested, right? No matter how you burn helium, it is not going to give you anything. Like, no reaction. Okay, no reaction, chill, no reaction. So everyone in inert gases here, you can be sure that they are very chill. Helium is very chill, that's why we put it in balloon, because it's safe, right? Neon, argon, krypton, xenon, radon, everyone is chill. They won't give you any drama. That's why we call them inert gases. And if do you have any friends who take chemistry? Do you have any friends who take chemistry? Chemistry students, they also call it noble gases. What is noble? Noble is very 高贵. Noble, 很高贵. So these people, you see, if you're very rich, right? If you're very rich, you don't mess with poor people. Because you think they're very low class. Like, I don't want to befriend poor people. So they call them noble gases because they're very 懒习 one. Okay, because they're very 懒习, they very action one. They sit at the most right side of the table. You see, it's like we are having a class here. Everyone is having fun. These guys, they just choose to sit at the most corner of the room and say, hey, all these cheap people, I don't want to mess with them. I don't want to friend them because they're all poor people. I don't like them. So they sit at the last row, at the last group. Okay, so that's all you need to know. That's all you need to know. Okay, let me summarize everything. Let me summarize everything. Okay, this is your periodic table. Guys on the left, girls on the right. Okay, metal, non-metal. Semi-metal, the half guy, half girl one is in the middle. 1, 2, 2, 2. Right? X-axis is group, Y-axis is period. Okay. What else? What else? This table is arranged according to increasing proton number, going to the left to right, going to top to bottom. Okay, proton number 1, proton number 2, proton number 3, 4, 5, 6, 7, 8. And everyone is arranged according to the same characteristics. Same group, same chemical property. Same group behave the same. Same group behave the same. Okay, that's all you need to know. That's all you need to know. You're not memorizing anything. You are not memorizing anything. You just need to know where they are. Where they are. How do you look at this table? How do you use this table? That's all you need to know. And one more thing to add on before I end this thing. These metals here in the middle, we call them transition metal. You know what is transition? Transition is 转变. Why we call it transition? Okay, in BM, transition is called peralihan. You know what is peralihan? You know what is peralihan? If you suck at standard 6, you have to take another class before you go form 1. You see, this is standard 6, this is form 1. In the middle, we have peralihan, transition. So these metals, we call it transition metal. They are weird. Transition metals, they are weird because all of them have colors. And they will change their color time to time. That's why we don't really mess with them. We just know them as transition metal. Okay, so are you okay with this? Are you okay with this? I summarized everything for you already. Okay, no difficult here, no drama here. Should be pretty simple. Okay, so your take-home point for today. Your take-home point for today is only two things. Number one, atom, molecule, ion. Atom is metal, molecule is non-metal, ion is metal plus non-metal. Okay, and then you have your periodic table. Okay, where is your metal, where is your non-metal, how are they arranged, increasing proton number, what is group and period, where is the transition element, transition metal, why are they in the same group, things like that. Okay, so I'm not going to bother too much with this today. Let's go to the exercise, shall we? Okay, let's go to the exercise. Before I begin, right, can you try question 1 and 2? Okay, can you try question 1 and 2? I am going to go to the toilet real quick. Can you try question 1 and 2? I'll give you 10 minutes. Is it enough? Just 1 and 2. No subject, no long answers to write here. Okay, just 1 and 2. I'll be back at 5:15. Should be enough. 10 minutes, we can finish discussing this. Okay, I'll give you 10 minutes. See you later. Okay, hello. I am back. I'll give you the answer if you don't mind. And please check your answer. So 3 types of particles. You already have the answer down there actually. So you have atom, you have molecule, you have ion. Okay, so the first one is molecule because there's 2 atoms here, like oxygen. Plus minus is ion. Single alone is atom. This one easy. So what is atomic substance? That is a substance made up of only one type of atom. Okay, D, molecular substance, is a substance made up of more than one type of atom. Okay, atom is one atom. Molecule is more than one atom. This one easy. Okay, so E, state the types of substance based on the diagram and the meaning. So made of only atomic particles. Atom example is your metal. So we have 2 metals here, iron, zinc. Molecule is non-metal, so you have your water, oxygen. Ionic is metal plus non-metal. That is your sodium chloride. Okay, or you can say salt. Then you have your iron oxide, which is your rust. Okay, easy. So number 2, state whether the following atoms are objects are atomic, molecule, or ionic. So copper is a metal, so it's atomic. Water is molecule because it's non-metal. Iron, atomic. Sodium chloride, ionic. Okay, please let me know if you're not okay. So same thing down here. Iron sheet. Iron is a metal, so atom. Ice cube, non-metal, molecule. Common salt, ion. Sugar is a non-metal, so sugar is molecule. Marble is an ion, because marble inside has calcium, which is an atom, which is a metal, and you have oxygen inside also, so it's an ion. Copper wire is atom. Lime water is also ion, because inside is calcium also. Oxygen molecule. Helium, this one, sir, this is non-metal, right? But this is an atom, because this is an inert gas. This is a special gas, special case. So this is atom. Okay, so example of substance is made of iron in the form of ions. Iron is originally metal, which is an atom, but now they want the ion form. which is your iron oxide. Okay, your rust. So take correct about ionic. Ionic is when metal combine with non-metal. Okay, correct. Ionic substance has low melting point and boiling point. You must say, so how do I know? Just think of your salt. Can you melt salt easily? Can you melt salt easily? No, you can't. Salt will melt at 800 something. So this is wrong. Positive ion and negative ion, they join together by strong electrostatic force. Yes. Okay, what is this? What is strong electrostatic force means? They have a strong force attracting towards each other, just like this. Okay, so I guess that's all. So do you have any question? Do you have any question? I'm just doing something easy today. As you can see, compared to chapter 5, genetic, compared to chapter 6, the movement one, the muscle one, compared to chapter 7, hormones, this chapter is very easy. Okay, there's only 3 things to remember. Next week, we shall go to periodic table. This one. Okay, so if you have no question, I will call it a day lah. Okay, I will see you next Wednesday lah. So have a nice week. I will see you soon. Okay, so see you. Take care. Bye bye.